Okay, let me try to give you a little bit of help with section 10.1. This is a really important section. This idea of hypothesis testing plays a really big role in the field of statistics. So in this section, we just kind of want to get the basics, how we get it started and how we get it set up and that kind of thing. So we got two big objectives here. We want to be able to state the null and the alternative hypotheses, and that's going to be our main focus. And then this other idea of distinguishing between the two types of errors, we've got some slides in here and we might talk about it just a little bit, but that's really not going to be the focus. We want to focus on being able to be given a problem statement and being able to state the two hypotheses. Okay, so I don't know how you could not be able to notice it now, but we're always surrounded with different types of statistical claims. The ones we're given here: 4 out of 5 dentists prefer Starbright toothpaste, and less than 1% of dogs attack people unprovoked. Statements like these have a big effect on our lives, and right now I don't know how you could miss it. We've got all these coronavirus statistics out there that are making a big impact on our day-to-day lives. So hopefully you can see that being able to test these types of claims is really important. We don't want to just take them blindly. We want to know if they're valid or not. So that's where a hypothesis test comes in. If we have some type of numerical claim made about a population parameter, then we want to be able to test that claim and see if it's valid or not. So doing that's what we call a hypothesis test. So a hypothesis for us in statistics is when we have a claim about the numerical value of some parameter. So maybe we're making a claim about the mean or a proportion or the variance. In those cases, we would call those types of claims hypothesis. It's not exactly the same as you see in science. We're a little more specific when we're in statistics. Okay, so anytime we're setting up a hypothesis test, we're going to have two hypotheses. Okay, so the first hypothesis we're going to talk about is called the alternative hypothesis. Or sometimes you'll see it called the research hypothesis. The alternative hypothesis, instead of having to write out alternative hypothesis over and over, we'll write H with the subscript A. Okay, so, or we'll just call it HA, or the alternative hypothesis. And the alternative hypothesis is the one we're trying to see if there's evidence for in the data. You can kind of think about it as like the accusation that's being made, and then we look to see if there's enough evidence to support that accusation or not. The other hypothesis we're always going to have is called the null hypothesis, and our shorthand for that is this H with the subscript 0. Null is another name for 0, and instead of having to write null hypothesis, we'll write H sub 0 for the null hypothesis. And the important part here, the null hypothesis is kind of the status quo, right? So whatever we believe to be true before we make a statistical claim, before we make an accusation with the alternative hypothesis, and that's what's represented by the null hypothesis. And the important part is these two hypotheses are opposites. Okay, they're logical opposites. So if one's true, the other one has to be false. If one's false, the other one has to be true. They're complete opposites. There's no in between there. Okay, so the way a hypothesis test works is it's what we call an argument by contradiction, or what we call it a proof by contradiction, but we're not really proving anything here for 100%. But what we do is we start out assuming the null hypothesis to be true. So we start out assuming what we already believe to be true is true. And then we look at the data to see if there's evidence to support some kind of claim. I said you could think about it like an accusation that we're making with the alternative hypothesis. And if there's enough evidence to support our alternative hypothesis, then that tells us we can get rid of the null hypothesis, the status quo. So something can change there. And we'll talk a little bit more about that in a minute. So just a quick recap here. If we're testing a claim about a parameter, it's called a hypothesis test. When we do a hypothesis test, we have two hypotheses: the alternative hypothesis, That's usually the one we're trying to gather evidence for. The one I said you can think about like an accusation, or sometimes we'll call that the research hypothesis. And then the other hypothesis we always have is the null hypothesis, H0. The two hypotheses are logical or mathematical opposites. And then one other thing to mention about the null hypothesis that's really important, that'll really help you out, is that the null hypothesis always includes equality. So with the alternative hypothesis, we might be saying a parameter is greater than something or less than something or different than some number. With the null hypothesis, we always have equality with that. So the null hypothesis will always either say that our parameter is equal to some number, or it's less than or equal to some number, or it's greater than or equal to some number. That goes with the null hypothesis. And then our alternative hypothesis is either going to be less than something, greater than something, or if we're not being specific, we can just say it's not equal to some number. Okay? So those are our choices of symbols in the alternative. And then our choices of symbols with the null hypothesis, they all have equality included with them. Okay, so let's look at a problem here. Okay, an example. He says we've got this college, and the syllabi for online classes states students should expect to spend 10 hours a week doing coursework for each class. The director of e-learning concerned that students are being required to spend more than 10 hours per week doing work for each class. Got a little more on the next slide. Okay. Nope, never mind. Okay, we're going to try that again. Let's look at this one. So it says that Northwest Mississippi Community College syllabi for online classes state that students should expect to spend 10 hours per week doing coursework for each 3-credit-hour class. Director of e-learning for the community college is concerned that students are being required to spend more than 10 hours per week. Okay, so on this one, the accusation, you can kind of think about that. The claim that we would want to be testing here. Okay, you can think about who's making that claim. The director of e-learning is making the claim. Okay, and then the claim that they're making is that students are having to spend more than 10 hours per week. Okay, so that's going to be our alternative hypothesis, HA. And this one doesn't explicitly state it. It gets easier to pick up on this the more of these you look at, but this one, we're dealing with a mean. Okay, we're thinking about on average students are spending 10 hours or more than 10 hours per week on each class. So our symbol for population mean is mu, okay? And then the claim that we're testing here is that students are spending more than 10 hours per week, so that would be that mu, or mean, is greater than 10. Okay? Once you get one of the hypotheses, and which one you start with depends on how the problem is worded, which one's a little bit easier to get first, but once you have one of the hypotheses, we know they have to be opposites. Okay, so it's easy to get the second one once you have the first one. So we go to our null hypothesis. We're still going to be dealing with mu. The number we're interested in is still going to be 10, but we've got to have the opposite statement. So the opposite of greater than 10 is less than or equal to 10. And remember the equal bar. Okay, the equal bar has to be included in the null hypothesis. Okay, so every time we have a null hypothesis, it's going to have or equal to, or maybe just an equal sign in there. Okay, so that answer's in here. It's got the textbook discussion in there if you want to talk about that. So, I mean, if you want to read about that some more. So, let's look at another one. Okay. This one says, after learning that Peter Collot of Switzerland could hold his breath for 19 minutes and 21 seconds underwater, a group of students decided to conduct their science fair project around the amount of time an average adult can hold his or her breath. Part of the group found research to suggest that adults can hold their breath for 30 seconds while submerged in lukewarm water. This one's kind of wordy, so it goes on to the next slide. The other half of the group found evidence to suggest that the mean time is different if the water temperature is colder. The group would like to test this claim about adults holding their breath in cold water. So the claim they want to test is about people holding their breath in cold water. And we kind of have to work our way backward here to piece this thing together. So what are we testing about adults holding their breath in cold water? And that's that the mean time is different if we're in cold water. Different than what? What was it not in cold water? Okay, we got to go back a little bit more. says in lukewarm water, not in cold water, people could hold their breath for 30 seconds. Okay, so the claim we're trying to test here is that adults can hold their breath for a time different than 30 seconds. Okay, so these can be a little bit tricky. All right, so different, anytime you see something that just says different and it doesn't say more or it doesn't say less, okay, the way we typically write the alternative hypothesis, again, we're dealing with a mean here. We're saying it's different than 30 seconds. So the way we would write different, we're not saying more, not saying less, we're just saying different, is with the not equal to symbol. We're just saying that our mean is not 30 seconds. Could be more, could be less. We don't know. We might not even care. Okay. So then our null hypothesis, we're still going to have mu. We're still going to have 30 seconds. The opposite of not equal to is equal to.